Hello everyone, my name is Andrew. Today we continue learning Python, and today we'll talk about Python 3.10. So let's start. So the newest version of Python is out there. We can check it out, we can download it. It's not a snapshot, it's like a real new version of Python. And now I'll talk about it. I'll explain the new stuff that has been added to the language. Then I'll try to explain what direction Python is moving from my point of view, and then I will try to give you my own opinion about version 3.10. So again, the newest version with a lot of new stuff. So let's just start. That version was released like 2 weeks ago or 5 days ago. I'm really not sure. It was released recently. And the first and the most drastic change that was added is right somewhere there. It's right there. And again, I wanna point out that I will not write any code myself, so if you want me to teach you how to use specific thing in Python 3.10, then you can write it down in the comments, but I will not write any code right now. I'll just explain all of the ideas and try to give you the overview of the newest Python version. So what we need to talk about first. First of all, structural pattern matching, and I'll call it match case. So if you worked with other languages like C, JavaScript, C++, C#, Java, like any C-type language has switch case. And I think many of you know that Python didn't have a switch case. So if you don't understand what's a switch case, imagine that you have a lot of ifs with the same equal, so with the same equality signs. And in order to remove that and add some new and some more beautiful syntax, we have switch cases in a lot of languages. But Python developers, again, did it better because they added match case. So again, it's structural pattern matching, but yeah, it's match case. I think everybody will call it like that. So what is that? So as you can see here, or we have a code example here. So we have HTTP error function, which accepts status argument inside of it. And what are we doing right here is we say match status. So if our status variable is 400, for example, so I think, yeah, that's an HTTP status. If our status variable is 400, then we return bad request. If it's equals to 404, so not found, we return not found. And the same goes for every other case, again. So we are just simply doing status equals that equals that. And we can remove it and rewrite it with a simple if-elif statement, but I think that match case is much more better because in other languages like C, C++, JavaScript, we can really omit that match case. But again, Python developers, as I said it earlier, did it better. In what point they improved the match case? So in 99% of the languages, switch case, so again, switch case, match case, these are the same ideas, but the realization is different. So in C, JavaScript, C#, Java, so all the languages that I have ever used, switch case is just like a simple. So status equals to 400 or 404 or 418, or that case is like a default. So if all of those give false, that will execute. But if something executes, like for example case 400 executes, it will return bad request or do something with the code. So it's just like a normal default. And all of the other languages have that. However, what Python developers did is they added some really cool stuff to that match case. So I don't know why they didn't call it switch, maybe because again they added some cool stuff, or maybe because they thought that match is better, but in all the other languages it's switch again, but in Python it's match. So the first and the most cool addition is that. So it's like a combination of different cases. And that really struck me because when I was programming in C++, I often rewrote my switch cases because I added some new logic to my code. For example, I had like if our integer is 1, or if our integer is 2, or if our integer is 3 or 4. And that's the case, because you cannot write 3 or 4 in C language if you're using switch cases. And because of that, I was required to rewrite my code use ifs. But in Python, again, we can use, and Python, again, everything is better, and we can use that or syntax. So that means that in our case, status can be 401, 403, or 404. That's very cool, but that's not the only addition. Next addition is, they show us that we can omit using like default case. That's cool. The next addition is that. So again, if you worked with C, C++, or any other language that uses switch cases, you know what I mean. Because in those languages, you can literally just compare very simple structures. But in Python, they took it further. Because now we can compare tuples, we can compare lists, we can even compare our own classes. So yeah, that's an example of tuple comparison, and that's an example of class comparison. Because as you can see now, we have location function, very stupid name for a function from my point of view, but still, we have location function, which accepts a point. And then we made our own class, and we are making switch case or match case for that specific class. So that's the reason, because in other languages, you can only compare very basic structures. But in Python, again, what you can even do is you can even put your own classes inside of a list and then compare it. So there is a lot of stuff that you need to learn about match cases, and I need to learn as well, because I have never worked with them. That's the brand new addition to Python. And the next cool thing is that. So it's just like, oof, it's so good. So match test variable, then we have like, again, a tuple comparison. So warning code 40 or error code, and again, wildcard, anything. So really, match cases are very powerful. And I think that in the future, like in a year or so, we will see a lot of code being rewritten to match cases, and Python will be much cleaner. Because now what we can do is we can compare, for example, if our test variable is a tuple which consists of warning, code, and 40, or if that tuple is error, code, or anything else. So yeah, if you haven't read that text, then I'll explain it to you. So that underline means anything else. So anything else can be used inside of a tuple. So that means that we can use it like we can literally do whatever we want. For example, if you have a tuple that should, as is that case, for example, you have logs, and as you may know, logging, so log entries are divided using specific levels. For example, info logs, debug logs, error logs, and warning logs. As you can see here, imagine that you have a system that notifies when your program has an error. For example, your user clicks on something and your program pops up with the error 500. But again, error can change. For example, error 404. And for every error, you write a log entry. But then you need to filter all of the logs that have error inside of it. And what you can do with that syntax is really just add error, error level, then some code, I don't know what is that, but then you can add anything. So that anything itself is just like a big leap in terms of match case. Because again, in many languages, I think switch cases are really basic. So it's just like switch case. So if something equals something, if something equals something. But here, what we have is like we have a really great addition to ifs. So I think that a lot of ifs in the future, so a lot of if statements in the future, will be rewritten to match cases. Because again, those can be really clean and really great. Another great addition is that. So again, as I said earlier, there were cases when I coded in C or C++ programming languages, and when I added another condition to my switch case, I needed to rewrite it, because in those languages, switch cases do not have conditions. And if they have those, they have those in only the executable of your switch case. So that's not what I wanted. But here in Python, we have guard. So guard, it's like case point xy if x equals to y. So that's how it works. That's very powerful. And again, we can literally incorporate ifs inside of our match cases. And I think that, again, a lot of match cases can be a very great addition to the Python language, and that addition itself can be that addition itself says that the new update is worth it. It's like the perfect update that you can think of. Only if we are talking about match cases, but that's not the only thing that that update brought to us. So yeah, there are some other key features, you can read about those, but I will not explain those. Okay, that's what I really like, because a year ago I had a video where I explained that you always need to use encoding. I think that if you seen my old videos, then you know that I always explain. I think it was called like open function, or why you use open, or print and open secrets, something like that. But what I said in that video is that a very common bug in Python is omitting encoding parameter when we open a file. So why is that a bug? Imagine that you have a Windows computer and then you have a Linux computer. If you open, for example, right here we can see that with open data JSON. So if we open that data JSON file on our Windows computer, so we created without an encoding parameter, so encoding equals UTF-8, then what does that mean? That means that we use the encoding that is that lies inside of our system. So as far as I'm concerned, it's Windows CP1251. I'm not pretty sure, but yeah, it's not UTF-8. That's what I want to say. But then, if we transfer that file to Linux system, it cannot open. It can be corrupted. Something can happen. But now, every time we open a file without an encoding in that file, what we have is I don't know if you can. Where is it? Yeah, we have here encoding warning is added. So it emits encoding warning when we don't have our UTF or any encoding inside of our file, inside of our text.io wrapper. So text.io wrapper is the object that is returned from open function. That's how it works. So that is very great addition, because yeah, I said about it and I'm glad that they added it to the language. Now what I want to do is go a little bit go to the start of that document, and I quickly want to say that parenthesized context managers are a really great addition. So you don't specifically need them in every application, but they're really great, because sometimes when you want to open two files and interact with both of them, you can use context managers. So if you don't know about context managers, it's like you open a file and then you automatically close it, because in terms of a lot of classes like files, database connections, transactions, so a lot of things in programming require to be opened and then they require to be closed, not to waste resources. And if we're talking about files in particular, we can use with statements of context manager in Python in order to open it and close it automatically, even if exception happens, because that's a typical error in a lot of web frameworks. So if you open a transaction, for example, to the database, or open a connection to the database, then exception happens in your code and that transaction is never closed. Therefore, your database wastes some resources on that connection, transaction, etc. But here we have context managers in Python, and it's probably better to use them always, because again, they open and close things that you need to open and close for you. So you don't need to worry about anything. But that's the problem with context managers. That was the problem with context managers, because they were not as so it was really hard to work again with 2 files, 3 files, 4 files, or not specifically files, but with 4 classes, objects, and so on. But now what we have here is we have a parenthesized context manager, so we can open not only one object inside of our context manager, but 2 objects, like ctx manager 1, example 1. Okay, let me quickly check my recording. Everything is great. So yeah, we can open those like that. So nothing really fancy about that. It's just a great addition that should have been in Python a long time ago, but still, it's a great addition, and I really like it. Yeah, as you may already know, I really like that 3.10 version, and I think that's the perfect addition to Python programming language. Here we have some errors. That's really useful. Yeah, that sometimes is really useful, because as you know, in Python, we didn't have like very descriptive errors. For example, yeah, that's one of the things. XZ for Z in range 10, TW. I don't know what that means. Maybe those are some lists, but whatever. We needed to have parentheses for those, and as you can see now, it says generator expression must be parenthesized. So yeah, I think that's really cool. Okay, Yeah, so that's really cool. So now we have like very descriptive error messages. That's a great addition because now we will not have to look for the errors as 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 long as we did before, because now we have really descriptive messages that show us the real case, the real error, so the real exception. Okay, that's really cool, but that's just a great addition. Again, all of those additions are really, really great, and I'm just saying like, oh, that's a great addition, but from my point of view, it's the best addition that could have been added to Python, because that's just what we needed. That's nothing like very fancy. There is nothing like very bad. It's just like the perfect addition, the perfect version. Okay, and that new type union operator, that's what I wanted to talk about, because that thing itself, it's not like, oh, okay, it's great, because if you use typings in Python, and let me just quickly remind you of what typings are. So if you know Python is a dynamic programming language, so we can have a variable that points to an integer and the second after it points to a string. For example, in Java, we cannot do that because we have like string equals to something. But here we can do that. And because of that, it can be very confusing for other programmers what type of variable you want to use, what type of function, what type your function is returning, so what is happening with your variables. And because of that, we can use typings in Python. They are not brand new. They were like from version 3.6, maybe 3.4. I'm not really sure. I think 3.5 or 3.6. But they were in Python for a really, really long time. But now, as you can see, the only problem with, so again, typings are just like a hint for programmers. So these are like just comments for programmers and for ID. So for example, if I'm saying like number, two dots, I forgot how to call them, integer, I'm saying like, okay, number should be an integer. And again, the only problem with typings is that you need to know other stuff if you want to use those. For example, very often your function can accept either a number, an integer, a float, a decimal, or any other thing that can be added, subtracted, and so on. And if you want to show your programmer that you want to either accept an integer or a float, what you can do is use like union int comma float. So that is the syntax of saying like, okay, so that number variable, again, it's not like a rule, it's just like a comment for the programmer. But let me finish with what I want to say. Union int float, it says like number variable can either be integer or float. That's what it means. And that was a hint for the programmer. So that those were comments for the programmers. And yeah, that line says that our function def square returns either integer or float. So yeah, I think you know that if we just multiply it here, so it can, if it accepts an integer, it returns an integer, else it returns a float. So that's how it works. However, again, if you wanted to use typings to their max potential, then you need to know about specific syntax, specific classes, specific things like union. And that was the problem, because a lot of programmers don't know how to use those. But now, as you can see, new type union operator. So now we don't need that union in Python 3.10. Now what we can do is use either integer or float. Integer or float. So that's how it works. And I want to say that that is maybe the best addition to Python. So typings are maybe the best addition to Python, because I explained why I mean that. But yeah, as you can see now, you should not write typing or union int float. What you can do is write integer, like that line, so or float. You can use that in is instance. So yeah, if you want to check that your object is either an integer or a string, so it's a class or a subclass of an integer or a string, then you can do that. But that's new type union operator is really, really great. But what I want to say, that now, from my point of view, Python moves to a new direction, because it's a dynamic programming language, like for example JavaScript. And if you ever worked with JavaScript, then you maybe heard of TypeScript. So TypeScript is like a JavaScript with type hintings. so JavaScript with types. And why is it beneficial? Because when a developer knows what that type should be, how that thing works in terms of types, classes, objects, um, the developer knows, okay, so that should be that class should inherit from that, and because of that, a lot of bugs are removed during the development. But in Python, we didn't have that until we invented, so not we, but Python developers invented type hintings. But again, they were very complex because of the new syntax, new classes, new aliases that you needed to know. For example, union. That was the thing with the list. So in previous version, you had like, or let me open my terminal. You had like list, then for example integer, string. Now, if we're talking about Python 3.9, so they added that in the previous version. So for example, in Python 3.8, what we need to do in order to have a type hinting for a list of integers, we need to write it like that. But in Python 3.9, what we can do is write it like that. So list, integer. And that syntax is much more familiar, much more friendly for all of the Python developers. What does that mean? That means that Python moves to a new direction, a direction of type hintings. That direction, what it adds to the language. So if you have ever worked with fast-ip, pydantic, then you probably know what it can add. So that is just like a comment for the programmer, but also it can be a rule for the programming language. So I think that in a year or so we'll see type hintings in almost every library, and their mainly usage will be like validators, again, comments for the programmers, and yeah, we just see a lot of type hintings that will validate our information. So if you again worked with pydantic, if you don't know about pydantic, it's like a library. Let me just show you pydantic. Yeah, so it's just like a library. So as you can see, class user base model. It's a library of serialization. So for example, we have, yeah, as you can see here, external data. We can put it to the user model from pydantic, and then we can use it as a class. It's like a really great library, and if you have ever worked with Flask or Fast API, then you probably used it. Yeah, so as you can see now, what we have here, ID, again, oh, semicolon, it's called semicolon. Oh, wait, no, it's not, no, semicolon, I think it's, okay, double dot, and integer. So what is that? That says that our ID should be an integer. And if we don't have it as an integer, so if the type is different, we throw an exception. And yeah, as you can see, that's the syntax I was talking about earlier. So list with the capital L at the start. So that's very inconvenient for Python programmers because again, as you can see, from typing import list optional. So again, we have optional, but I think that we will see not optional, but daytime and then question mark, because yeah. So what I want to say, that in the future we will see type hintings as real structures, real syntax in our programming, in our Python programming, because even now we can see those, like that is a validator. So if, for example, I use external data and then put ID as an invalid integer, so here is a valid integer, so I can just literally translate it to an integer. But if I put, for example, A, B, C, D, E, F, G, that will throw an error. And why is that really, really powerful? Because we don't need to write any additional code in order to check for the variable type. Python is a dynamic programming language. That is right. But still, there are tons of moments when we need to check for the variable types. And if we can do that with the type hintings that are getting more convenient with every Python version, then that will be a new era of Python. With literally, it will be like TypeScript for Python. That's what I'm thinking about type hintings, and that's why I like that addition the most. Yeah, match case is alright. Well, it's like perfect. It's exceptional. But I think that addition is the best out of all of others. So yeah, that's what I'm thinking about that. So yeah, as you can see here, we have type validators, and we'll see those type validators for all of our Python variables in the future. So again, I think you will be able to omit them if you can, if you want to. But yeah, you'll just be able to write like number and that's it. But if you write type hintings, then that will mean that you want to use like type type checking. So yeah, that's what I mean. And yeah, as you can see here, optional datetime. So even now, typings. So yeah, we have like typings, or sorry, not typings, but typing module in Python that contains all of the type aliases. So type aliases are like just very complex type hintings. Like we have a simple int or float, or we have like a list of or an asynchronous coroutine of, and so on, so on, so on. But I think that in the future, Python developers will have to remove the majority of the stuff from that typing module, and they will move towards very simple and very basic Python type hintings. And that is all right, that is exceptional, because now I do not need to even know about union. What I can do is just write, and even if I don't know about type hintings, that I can think of like, okay, what if I want integer or float? So that is very, very user friendly or programmer friendly, if I can say it like that. So that's how it works. That's really, really great. And again, I think that in the future we'll see Python with type hintings that will work as type validators. So I think that is very great addition, as all the others. So yeah, we have type aliases, but I will not talk about those. Guards, and yeah, now we have like a lot of improved modules, so those are very specific. Oh, this util was deprecated, so yeah, and it will be removed in Python 3.12. That's very unfortunate, but still. So yeah, there are a lot of things here. You can read about those, but the most important additions, well, all of those are very, very important. Yeah, changes in C API, changes in Python API. Yeah, there are a lot of things. Unicode string was removed. I'm not a C Python programmer, but still I want to try it. And I tried it once, but it was awful for me because I haven't like worked with C for 3 or 4 years. But still, I think C is a very great language, so watch my video why you should never learn Python. Again, you should learn it, but why should never pick Python as your first language? But again, I'm moving out of the main topic. That is all of the most important additions in Python 3.10. Again, it got faster, it got better, it got stronger, it evolved. I think that is the perfect version for Python. That is the perfect new version for Python. But what I want to say to you is that if you want to delete Python 3.8, Python 3.9, 3.7 and move to 3.10 immediately, that's not the right way to do it. Of course, you can install it, you can try it, you can work with it, but what I want to say is that you should never hurry, because now 3.10 is really brand new, and there can be a lot of bugs, very hidden bugs, a lot of bugs with it, a lot of problems. They will be fixed, and we'll have a lot of patches as we do it with every Python version, but still, Python 3.10 is really, really broad right now. And even Python 3.9. For example, a lot of cloud providers have very specific services for different versions of Python. So as I see it, the main versions right now are 3.8 is the main version of Python. 3.7 is like a little bit deprecated. And 3.9 is the next version that will move on. But 3.10 does not have all of the libraries, all of the modules, all of the frameworks, all of the bug fixes, all of the really things that we have in Python 3.8, 3.9 already. And I think that it's not the best idea to move all your projects to Python 3.10 right now. Again, you need to wait. But I think that in the January maybe, or in the maybe then June, July, or August, we will move to Python 3.10. Not completely, but still we will move it. We'll move to it in August, somewhere around here, maybe in the start of spring. But still, I don't think that you need to move to Python 3.10 immediately. You can try it, you can learn it. That's always a great thing to do because knowledge enlarges our potential, but still, if you want to move all your projects to Python 3.10, now it's not the time. Again, stick to Python 3.8, 7, or even 9. And yeah, that's what I wanted to say. Again, that version is not, there's nothing wrong with that version. It's like a perfect version, a perfect addition to Python. But what I want to say is that you should never hurry. Again, there are no libraries for Python 3.10. Well, I think there are some right now because it was like 2 weeks or 5 days, and I have no idea when it was released. I had it in the news, so yeah, I had no idea when it was released. I had the idea about all of the Python update, so all of the new things in Python, but I had no idea when it was released. So yeah, that's how it works. But again, as I want to say, you should never hurry. So wait a little bit, work with Python 3.10, because that version, it will not like roll back, will not have like a very, I don't know, git hard reset, will not have those types of things, and clearly we'll move to Python 3.10 in the future. But now I think that is not the right time to use Python 3.10 for all your projects. Again, it's a great version. I do not want to say anything bad about it, but still, you don't have all the potential of Python as you have it with 3.7, 8, and 9. So that's what I wanted to say to you. Thank you for watching. If you want me to write some code in Python 3.10, write it down in the comments. Subscribe to my channel. My name is Andrew. Again, thank you for watching and good luck.